London meetup, so I hope you find what I have to say interesting. My plan is to take you through kind of the journey of my company Tewke, that is trying to kind of revolutionize the smart home space using our light switch called Tap. And the UI for which we've built using Flutter. So who am I? I'm Matt. I graduated from Bristol 5 years ago. And I was one of the first engineers to work at Tewke. And I'm now the head of front-end development at Tewke, which sounds more impressive than it is because it's just 3 of us. And a key distinction I want to make is that I'm not an embedded engineer. So we're working on an embedded device, but through the power of Flutter, I don't have to be an embedded engineer. So what is Tap? Tap is the smart home control interface that we've built to replace the light switch. It can control the lights, but it also provides a touch point for other smart home control, giving users insights into their homes and controlling other smart home devices. So in the first image, you can see kind of the scenes, which we use to group control devices together. Then we've got the health screen, which gives users insights into temperature, air quality, CO2, and then aggregates those into a kind of health score. And all of the information it pulls from sensors on the device. And then we've got energy, which pulls from the power consumption of the lights themselves, but also integrates with smart tariffs, Octopus Agile to show when energy is cheapest and things like that. And I actually have a demo unit here, which isn't powered on, but this is that's kind of the device that replaces your light switch. So today I'm going to take you through why we chose Flutter in the first place, as a fresh graduate with no industry experience really, and then how we professionalized our approach using Yocto by building Tewke OS, which is a custom OS, and then I'm going to take you through what Tap needs to do, the functionality it needs to provide to power the features that we want to give to our customers, and then how we use Flutter to achieve those goals, and then how we've managed to reuse that Flutter code to enable factory testing during the manufacturing process. So to start with the Flutter decision, my boss came to me 5 years ago and said, I want a mobile app that works on Android and iOS, and I also want an app on my light switch. Go. So I went off and did a load of research. I started off Swift Kotlin for Android iOS, but then went straight to React Native because I was like, that's the big player for cross-platform development on mobile. But then I didn't see a way for that to work on an embedded device. Started looking at technologies available for embedded Linux, saw that a lot of apps were made in Electron and GTK, and then stumbled across Qt in C++, which seemed to be the go-to for kind of embedded applications, and they were able to do mobile as well. The thing that put me off was the developer fees. You have to pay a fee per developer seat, and every device that gets shipped, you have to pay a kind of licensing fee. And that's when I came across Flutter, which seemed to kind of hit the nail on the head. They had an ethos of cross-platform development. They had, I think they had Android, iOS, all the desktop environments, and web was in alpha at the time. So I thought, this is a safe bet. They're not going to pull the rug out from under me and then stop supporting desktop development. So my thinking was that we've got these Raspberry Pis that in the office that we want to put our UI on. I'll just build a Linux desktop app, get the Raspberry Pi to run Linux, and then I'll put the application on it. That was the first naive decision because my Linux desktop with an Intel chip is not the same as a Raspberry Pi running Linux because the chip architectures are different. When making the Flutter decision, I didn't know this. I didn't realize this. And then I spent 2 months banging my head against the wall trying to cross-compile the Flutter engine for a different chip architecture. And this was before kind of Flutter Pi, before kind of the more common ways of getting Flutter onto these embedded devices. But we managed to do it. And then just as a bit of an insight into startup life at that time, we had these demo units which were running our UI, which is basically, this is a Raspberry Pi inside a 3D printed case, and we kind of plugged it into the wall. This did have a plug on it, and that ran our UI and controlled these Lightwave smart light switch controllers, so we could kind of demonstrate our smart home experience to investors that came in. So those are the demo devices. The code would start on my computer. I'd push it up to a GitHub code repository. I would then have a builder Pi that I plugged into power from my laptop, SSH'd into, pulled the code. Because it was running on an ARM64 chip, I could just Flutter build, and then I would then push those assets up to another GitHub repository. I would then run around the office turning off, restarting all the demo units so that they pulled the new code, and then they'd have the new version. Needless to say, this is not a scalable way of delivering code, but it's what we had at the time. We then hired an embedded developer who managed to professionalize everything, managed to discover Yocto, and for those who don't know about Yocto, it's not an operating system. It builds the operating system for you, and you're able to customize all of the different layers which go inside of that. So we were able to customize exactly which things we needed, and for Flutter, to enable Flutter functionality, there's a Meta Flutter layer, which uses Flutter Pi as the embedder to then work on our custom hardware. Our embedded engineers would like you all to know that it was actually very, very difficult to do all of this. They weren't happy that I was coming here talking about how easy it was, so they just wanted you to know they needed a custom fork of Flutter Pi. They had to implement Flutter lifecycles themselves. They had to manually map the pixel density. They had to create audio pipelines with GStream for the audio players. They had to create a custom watchdog, so if the UI stops responding, then it restarts the application, and then a lot more. But from my side, it was really simple. So now, fast forward to the future, we've got a nice custom operating system, we've got a whole way to roll out software updates, and we've got a fleet of devices with customers. What does the tap actually need to do? What functionality do we need it to be able to achieve? So first thing is connectivity. So when the user first gets their device, they need to be able to get it online, connect to their Wi-Fi network over Bluetooth, and then also network management. We've got lighting control. It needs to manually drive the lights connected to the wall dock. There's kind of manual hardware control. So these are the kind of things that on a mobile application you may not think about, but because this is the sole UI for our device, we need to expose all this functionality to the user. So then screen brightness, sound output, reading all the sensors in the hardware, using that data in the UI, pushing up to the cloud so we can access it in the mobile app as well. Interaction with the screen, so we detect motion, capture touch input, and because we don't want the screen to be on all the time, we have a Doppler radar in the device. As the user approaches it, the screen wakes up. When there's no motion detected, screen goes to sleep. And then just the general system management, reboot, power off, factory reset, which we all have inside the application, with UI written in Flutter that calls down into the hardware. So under the hood, just some context for those people not so familiar with lower level like Linux systems. All of the systems and services on Linux are started up by systemd. So systemd is the first process to start up when you boot up a Linux device. It's the last process to terminate when you shut it down. So that is the thing that manages starting up every service in the correct order, so that all of the dependencies of a certain service start before that service does. Then we have the actual system services themselves. So for example, Conman, which manages Connection Manager, which manages Wi-Fi and things like that, Blues for Bluetooth, and then our own custom services, which we've written to manage our own hardware. And Then finally, we've got dbus, which stands for desktop bus, which is a messaging protocol which allows all of these system services to communicate with each other. Because otherwise, they just run in isolation and can't actually communicate. And in terms of coordination of these, the application written in Flutter is kind of the brain of the device, which communicates with all of them over dbus. So I don't think I'll have time to dive into every feature in much detail, but I think onboarding is quite a good use case because it's something that I guess when you ship a mobile application, you're assuming the user has an internet connection to their device. You don't have to set one up for them. So, like I said, when they receive the tab, it has no internet connection. So, as they when they first plug it in, they swipe up, scan the QR code with the mobile app, and when the QR code is displayed, that provides an advertising code, because the tap is advertising itself over Bluetooth, and then the app can then connect to it automatically. And these are the interfaces for the kind of two stages of the onboarding process. So in the Bluetooth service, it will start advertising, and then basically once the device is connected, it calls into this Gap Manager. And during Bluetooth onboarding, the embedded device will basically expose Gap generic attributes over Bluetooth, which the mobile app can discover, and then it basically provides an API functionality to trigger a scan for networks. So the tap will scan for local networks, return that list to the mobile. The user will then select a network, enter a password, and pass those back down to the device. It then needs to feedback if the password is wrong, or if it was successful, to move on the onboarding flow. And I will say that our mobile app is also written in Flutter, which does simplify the whole process. We can use blues on both sides to handle the Bluetooth interaction. I do think for the exposure of GAT attributes, we did have to make some modifications to the package, because I don't think it's that common a use case to be on that side of the development, whereas connecting two Bluetooth devices is a much more established use case. And then once it's online, we allow the tap to send up an onboarding request, which then allows the user to add it into their home, essentially. So that's the onboarding flow. With networking, the one thing we've discovered over the past 2 years is an appreciation for how much the operating system will handle networking for you, and how much of a nightmare it is when you roll out an update and 10% of your users' devices go offline, and you have no idea why, because you think you've written everything correctly and it's doing what it's supposed to do, but for some reason the router's sending an invalid key message, or the device will just randomly fail DNS and not be able to resolve any URLs, so you need to reset the Wi-Fi technology and restart the service. All of this has been trial and error. And I will say that all of it has been very easy to do with Flutter. The problem's quite difficult, but the framework has been really quite easy to work with. On the left here, we've got, so I mentioned Conman, which is Connection Manager. This is kind of the state machine which the Conman service will exist in. And it will kind of go through these stages as it connects to a service, and we just kind of work. We have our own state machine inside the Flutter app, which will then work with this state machine to kind of get it into good states and make sure it's doing the right thing. But a lot of trial and error and idiosyncrasies from certain brands of routers. As an aside, there's a known issue with ASUS routers, which will, to stop proxy scanning, will basically just send a \n to devices, which will basically kill the network capabilities. So we've had to account for that as well. So we're replacing the lights, so it needs to be able to control. We're replacing the light switch so our device needs to be able to control the lights. The way we do that is that we have, you can see in the render, we have these small pins on the back of the device. So we have, this is the part which gets wired into the wall through the terminals in the back, and then all communication happens over one of these pins using our own custom protocol. And then that attaches, you can see the pins in the back of the device there. And that again is handled by dbus. So we have a system service running in Rust, which exposes a dbus interface. The Flutter application can then call into that interface, call the methods, get the data that it needs, measure the power. Like I said before, my life has been made a lot easier by the embedded developers. But I think just dbus is something that you may not come across in regular Flutter development, but I think it's just a very cool application of Flutter. User interactions. As I said before, the app is always on, which is another use case which isn't very common with mobile apps, and is something that is generally handled by Android or iOS. So the way that we handle this is that we listen to proximity signals from the radar, and because of the clever work our embedded engineers have done, they come through as near, far, none signals. And then, because as I said, the Flutter application is kind of the brain of the device, it will then decide what we want to display on the screen based on those different signals, or if we want to call into a custom plugin to set the screen, update display state to false, and just turn the screen off, basically. And then another thing that we had to figure out as well was the system management side of things. These are also all use cases which our designer, so our designer based in Spain, very excited about all the sexy screens, very easy to forget all of these screens. So I think if you use the device, you will notice a distinct design difference in the normal UI compared to the Wi-Fi screen or the system management screens. But like I said before, reboot power off functionality, kind of system information, there's kind of logging capabilities. So if you scroll down that screen, we basically just output the error logs because our customer devices were going offline. We couldn't get them back online. We couldn't pull logs from them. So we did have to ask customers, like, oh, go to this screen, scroll all the way down, click on logs, take a photo, send us the photo. What does it say? Which we probably could have streamlined, but yeah, that's how we were doing it. And then, yeah, so we have kind of basic Wi-Fi management, but it is just kind of show the state and be able to forget the network. And then we have the circuit configuration for the actual wall dock. Because in terms of how you've wired it up, we need to drive it in different ways. Cool. So yeah, so those are all the kind of use cases of the normal application. But then one of the benefits of having our main Flutter application, when we were going through the manufacture process, it was quite arduous. We had to kind of plug into a debug port. Our embedded engineer had to kind of manually run all these different hardware tests, had to check each component in kind of isolation. Whereas now our manufacturing engineer can basically put it together up to a point, get the screen attached, and run the Flutter test UI, which reuses basically all the same code and runs all these different self-tests, speaker tests, display tests, provides a provisioning QR code, which they just scan from a mobile app. That provisions the device in our database, adds all the data we need, and then they can exit test mode, which reboots it back into normal operation. One of the cool packages that we found as part of this was the Flutter-Rust bridge. And this is used for the hardware self-test because all of the hardware services were built using Rust because they're embedded developers, so obviously they love Rust. And they didn't want to touch any silly UI code and have to figure it out in Flutter. So They just wrote all their hardware tests in an isolated repository. Flutter-Rust bridge generates an interface that the Flutter code can call into. That returns me some lovely Flutter objects where I can get a test result class. It tells me if it's failed or not, gives me an error message if it hasn't. And they don't need to worry about any of that. They can just happily write their hardware tests as long as they run. I don't care. And I think it's a really powerful tool, and it's easy to see why it's a Flutter favorite as well. And then, cool, yeah. So in summary, I hope you've gained an insight into the world of Flutter kind of beyond mobile applications, and a bit of an introduction to embedded Linux systems and Yocto, a bit of an insight into the startup prototype development process, whether good or bad, and then how not to deploy software updates. Cool. Any questions? Yes.
How did you find the package ecosystem for non-iOS and non-Android?
It's a bit of a nightmare.
Yeah.
Yeah. Well, it's a lot of packages do seem to just work. They do just work across all platforms unless they have some kind of custom plugin behavior. In some cases, we've written our own plugins. So for the audio side of things, we can use a Flutter package, the audio players package, and just point it at our own custom plugin. But a lot of the time, if it is just kind of if it is just the dark code that is touching, it's fine, fine to use. But then, yeah, anything to do with video, anything to do with web, is a bit of a nightmare because it's all we have to write all the custom hardware side of it ourselves.
Nice.
Yeah.
Why does my light switch need to play audio?
You got to ask my boss that. Well, the idea is that it does replace the light switch, and this is a bit of a challenge we've had on the kind of marketing side because the RRP is a lot more than a typical light switch. So it's trying to kind of reframe it in a way where, yeah, it sits where the light switch sits, but it's not a light switch because we think of it as a home control panel.
Okay.
It's like this is where you'll control your entire house, not just turn your lights on, kind of thing.
Okay.
It just lives.
It like that.
Yeah. Yeah.
Cheers.
Okay. Cool. Thanks. Yeah.
Have you, to ask the question, have you ever wished that you did go with Qt instead of Flutter after all this time?
I've had a great time. No regrets, and I don't really have an experience with Qt, so I haven't seen the other side really. I do feel like because we have the mobile app in Flutter, I do feel that on the embedded device, Flutter does give a comparable experience, and I do wonder if Qt would have been able to do that as well. And it is just quite nice that all of our engineers who are working on the mobile app can just jump into the light switch app as well.
What's the longest time one of the devices has been up? And did you see many leaks?
Like memory leaks or... in terms of the longest time it's been up, I'm not entirely sure. I don't think we've seen any memory leaks. We have had running out of file descriptors before in early development from opening new network sockets every time a request was sent. But memory leaks, I don't think we've had many. I should have brought in embedded engineers to come and answer the lower level questions.
Do you track the apps like I'm thinking about like crash reports or any type of like system reports?
Yeah, so we have the ability to we have Grafana monitoring for all of our devices now for error logs and above, and then we also have the ability to dump the logs. So if a customer has a more complicated issue, we can find that specific device after we get their permission, because in case there's more sensitive information, and then we can basically dump their logs, which pulls all of the journal logs available essentially. And that's another thing that the Flutter application does, is it kind of aggregates all of the journal CTL logs and pushes those up.
So you gave a very good description of your development cycle.
Yeah.
running around to the other side of the office.
Yeah.
How is it nowadays? Like, are you able to remote debug? Like, or are you still having to build? Like, are you actually able to attach a debug session, for example?
Not to customers' devices, but
Sure. Like,
internally we can. Yeah, internally we can. So our kind of development cycle, we can do something really powerful is dbus over TCP. So basically, you can connect to real hardware. You're running it locally on your device, but it's as if you're running it on the hardware, making all the same dbus calls. The only things that are different really are kind of like the more core system calls or any plugins. But because of how much we use dbus for that hardware interaction, we can mock quite a lot of the functionality just by porting dbus over TCP to a local device. And then for customer devices, in terms of rolling out updates, we use a tool called Hawkbit, which we do refer to internally as Hawkshit, which we are working to make better. But it is actually, it's not that bad. We can basically do rollouts to a whole fleet of devices and kind of do staged, scheduled, stuff like that. So I'm not running around to customers' houses and, could I just turn your light switch off and turn it back on, please? Yeah.
Have you looked at any of the other Flutter embedded projects, like Toyota and Sony's?
I know of Sony. Very early on, one of the engineers from Sony was the only one I could find. Was it Hidenori Matsubayashi? Was the only one I could find with anything public about running Flutter on an embedded device. I haven't followed what they're up to recently, but when I was in the depths of it, I did email him for help, but he didn't respond. So I had to figure out myself. Yeah. Yeah.
Well, what kind of spec hardware is it? Is it running on?
I think it's 4 gig RAM. I don't actually know the specs off the top of my head. It's a Redaxa 3566 something chip. Yeah, I don't know off the top of my head.
It's more RAM than my Switch has.
Yeah. That should be in the marketing. Yeah.
All right. Any
Cool.
more questions, though? Quick one.
How many embedded engineers have you got?
I know you're trying to poach embedded engineers at the moment. So.
No, it sounds like a really important person in your business.
Yes. So we've got 3. One of them does kind of the firmware for the wall dock, for the microcontroller running in there, and then the other 2 are more focused on the panel, on the screen side.
Because that sounds like quite difficult to actually get Flutter running in a new operating system. Sounds quite like a big task.
I think the initial getting it running with Yocto and MetaFlutter wasn't huge. It's been all of the subsequent issues which have come up where like FlutterPy just isn't quite doing what we need it to, or it doesn't have implemented functionality, and that's where they've had to like put the time in. Yeah.
Okay. Any more? Last one? No? Okay. All right. Thank you very much, Matt.
Thank you.
I hope you've all enjoyed tonight. I'd like to